Has to do with midpoint and distance. Now, they give you these formulas, and they teach, in the book, they teach it with these formulas. To me, that's overcomplicating it, honestly. It just is easier to think about. These formulas work out in your math. So I would write them down just in case you decide you want to refer back to them. But honestly, you don't want to have to come into the test with any formulas having to be memorized. So instead, I would just make sense of what you're dealing with. So look, if you have a 0.24 and you have another 0.58, they're going to ask you to find the distance between the 2 points. They'll ask you to find the midpoint. So to find the distance, I personally always just draw myself a right triangle. So if you look at these two right here, I draw myself a right triangle like this. And then it's just really easy to think about. Distance. If I want to know the distance between the 2 points, I'm trying to find right here the distance between, the shortest distance between the 2 points. So then I write down the distance right here on the x-axis. If we have an x at 2 and an x at 5, what's the distance between them? 3 units right here. Does everybody see what I'm saying? If we have a y value of 4 and a y value up at 8, what's the distance here? 4. So we're literally just dealing with a right triangle with this at 3, this is a 4. So then it's just the Pythagorean Theorem to figure out distance. You would say 3 squared plus 4 squared equals our distance squared. So then from there you would add these up. That would be 9 plus 16, which is 25, equals distance squared. So then you would square root it, technically getting plus and minus. We can't have a negative distance. So for the context of this problem, we would throw out the minus 5 answer. Our distance is equal to 5 units. Look, that formula makes total sense. Look what they did. They took x2, 1 minus x2. They found the distance. Isn't that how we found the distance? We said if there's a 2 and a 5, that's a distance of 3. Do you guys see how we subtracted them technically? We then squared them, right? Because that's Pythagorean Theorem. Does everybody see where they're getting this thing squared? Yeah? Then we added them. So you looked at the formula. We added them to our distance of our y value squared. And then in the end, we have to square root it. So it makes sense. This formula makes total sense. It's just, to me, overcomplicating it to think of it like that. So distance was 5. Okay, so now what you're going to be asked is the midpoint. So look, we had this drawn. It got kind of messy there. It's literally asking you to find the middle point, which would be literally like right here. Do you agree? Somewhere right there. Isn't that midway between x and y, everybody? So here's what's a little bit harder for people to think about is think about this, right? If I said, give me those exact points, you have to think of it in terms of like, I start at 0, I'm going over about how many units? If you were to guess, how many units to the right are we going about, do you think? So if this is at 2 and this is at 5, what would be about the halfway distance, guys? Any guesses? I've literally drawn you a point. Take a guess. Looks about at 3-ish, 3.5-ish. Everybody agree? And then how high does it roughly look? About at 6. Do you guys agree that that would be about the halfway point? Let's see if our guess is correct. Think about it. You're literally trying to find averages. Average means halfway, correct? How do we find averages? We add up 2 things and cut them into the number of things you added. So we're going to be adding 2 numbers and cutting them in half because we're trying to find the average. So look at your x's, everybody. Here's x, here's x. Let's find the average from 2 to 5. So you would add them up. 5 plus 2 is 7, and then cut it in half. That is an average of 3.5. Does everybody see how to do that? Which makes sense. Look at the formula. x1 plus x2, divide it in half. Everybody see, we're just finding an average. And then our y values, let's find the average. We were up at 4 and up at 8. So on average, where would we end up? What's the halfway point roughly? You would add them up. So 8 and 4 is 12. Cut it in half. That would put you at 6. Does everybody see? You're just finding averages. So our midpoint would be at 3.5, 6. And then you should say to yourself, does that point look right? Go start at 0. Go 3.5 units. That does look about halfway. Up 6. Yep, looks good. Everybody see. Now, another way to think of it that some people might find easier. Last hour, some people thought it was easier to just once again think in distances. So think about this, if you like this better. If this is, we decided how many units? 3 units. Between 2 and 5, it was 3 units. What is 3 cut in half? A distance of 1.5. Does everybody see what I'm saying? So start at 2, because isn't that the first point? Add 1.5 to it. What do you get? Because we got to be halfway further. Does everybody see what I'm saying? So starting at 2, add 1.5. What do we get? 3.5. Does everyone see? And then what's the distance here between 4 and 8? 4. Cut it in half because we're literally trying to find the halfway mark. What would that be at? 2 units. Does everybody see what I'm saying? So if we were up at 4, we had to go 2 more units up. That would put us at 6. Yes? No? Maybe so. Do you like the first way better or the second way?
First way.
Sweet. I was just curious. Okay, so look, you're not always going to be given a picture. Draw yourself your own rough picture. It says find the distance and the midpoint. So I literally just draw myself a really, really rough sketch. It doesn't need to be perfect. So we're over 2 up 2, somewhere right there. I'll just write that in, 2, 2. We're over 6 up 4, so like further to the right and further up. So then I personally would draw myself in a right triangle to give myself the visual I want. So then I would once again write in, what's the distance from 2 to 6? Looking at my x values, that would be a unit 4 here. Between our y values, it was from 2 to 4. That would be how many units of distance? So then I would do 4 squared plus 2 squared equals our distance squared. So that would have been 16 plus 4, which is 20, equals distance squared. We would square root 20. You would check. If the square root of 20 comes out perfectly, great. But this one doesn't. So we're not going to write decimals. We're going to do exact answers. That would be 10 times 2, 5 times 2. So pull out a 2. 2 root 5 is the distance. That's the same thing as the square root of 20. It's just more simplified to write 2 root 5. So this distance is 2 root 5. There's your distance. Now, if I said to you, find the halfway point, that's about right there. Would you agree? I'm drawing a rough sketch. Now, let's think about on average where that would be at. So think about this. I, once again, sometimes think it's easier just to think in distances. It depends on the problem. So if this is 4 units, cut it in half, that would be 2 units. You guys see what I'm saying? 2 units. So if this was at 2 right here, if I go 2 units to the right, that's going to put me at a... what x value? Do you guys not understand what I'm saying? Or, like, I'm genuinely asking. I don't, like, do you understand what I'm saying by that? How about over there? Okay, so if you guys understand, where would that put me then? 4. At 4. Okay, then a height. This distance is 2. Cut it in half. That would be a 1 unit. Our y value was at 2. Go up a unit. That would put me at what height? 3. There's your midpoint. If you like the averages better, you would say, okay, so I'm going to average out 8 divided by 2, because you would add up your x's, which is 6 plus 2 is 8, divided by 2 equals 4. Average out your y's. That would be 4 plus 2 is 6, divided by 2 is 3. However you like to do it. There's our distance, there's our midpoint. Okay, let's do another one. So even if you're in the negative, like, make sure that you still think in distances. In my opinion, I think it's still pretty easy. So just make sure, like, look, let's do this one. I'll draw a little bigger. So if we're at -1 up 2 units, that's like down here, -1 up 2. Then we're over 3 up 9 units. So then drawing in myself a little right triangle. What would be the distance of the x's? From -1 to 3 is how many units? 4 units, right? We're thinking in distances. From 2 up to 9 is how many units? So then you would be doing 7 squared plus 4 squared equals distance squared, right? So then you'd be doing 49. 49 plus 16. 65 equals our distance squared. So then you would square root both sides. Our distance is equal to the square root of 65. So 65 breaks down into 5 times 13, which doesn't break down any further. So our distance is going to equal the square root of 65. If I said to you, find about the halfway point, we'd be like roughly like right here, right? Not drawn perfectly to scale because I'm doing a rough sketch here. So whatever you want to do. If you want to find averages, then do that. So in my mind, once again, it just depends on the problem. I'm going to just say, if this is 4 units long, cut that in half, that would be 2 units. I'm going to start at -1 and add 2 units to it. -1 plus 2 is 1. This is at an x value of 1. Everybody see? If you were to find the averages, are you still getting 1? 3 plus -1 is 2, divided by 2 is 2. It is 1. Sorry, 2 divided by 2 is 1. Are we still getting the same answer? Yes. All right, let's do averages for the y value if you'd rather do that. So average out your y values. 9 plus 2 is 11. Cut it in half. That would be 5.5. 5.5. And then you could look and say, does that look about right? Over 1 unit. Yep, that does still put me at the halfway distance. And then up about 5.5 units. That looks about right. Okay, good stuff. Okay, so this is my last example of the day. So more likely than not, they're going to give you ones like that aren't like perfect like whole numbers a lot of times, but it's the same idea. So it says find the distance and midpoint. So once again, this is why I just draw myself really rough sketches. So I'm over 2 root 2 up root 5. I'll just draw that right here. They're both positive, so I'll just call this 2 root 2 comma root 5. I'm then over 5 root 2s. That would be further to the right. Up 4 root 5s, so that would be up higher. 5 root 2s, comma 4 root 5s. Then you're drawing in yourself a right triangle. Thinking distances. If this one's at, so look at this x and this x. What's the distance between 2 root 2s and 5 root 2s? How many units? 3 units. I'm going to just go like this so I don't get too messy. What's the unit difference between 1 root 5s and 4 root 5s? 3 units, right? If we're up at 1 root 5, how many to get back up to 4 root 5s? 3 units. So to find the distance, you would be doing 3 squared plus 3 squared equals distance squared. So that would be 18 equals distance squared. The square root of 18 is your distance. If that doesn't simplify, you leave it. If it does, simplify it. So 3 root 2. Our distance is 3 root 2. So now let's find the midpoint. We know it's about right there somewhere. So I think maybe thinking in averages is going to be the easiest for this one. So to find the average, you would add up your x values. 2 root 2s plus 5 root 2s. And then after that, you would cut it in half. 2 root 2s plus 5 root 2s is how many root 2s? 7 root 2s, right? We don't change the root 2 part. All over 2. 7 root 2 over 2 doesn't simplify. Let's leave it as an exact answer. 7 root 2s divided by 2. Let's find the average of our y values. So that'd be 4 root 5s plus 1 root 5s all over 2. So that's 5 root 5s over 2, which doesn't simplify. 5 root 5s over 2. Is this making sense to everyone? Okay. Awesome. There would be your midpoint. There would be your distance. That's the end of the lesson. So pick about 10 problems in this section that kind of look similar. Once again, kind of hunt down the ones that maybe have some radicals in them for those, for good practice for the test.